Hi everyone. Hello. Welcome to the Jug. Hi. All right. Welcome to the May meeting of the Toronto Jug. Quick bit of housekeeping. We've sort of expanded our social media presence. We now have a Google Plus group thanks to Jeff. We have our mailing list thanks to us, and our meetup group thanks to Adib, who isn't here right now, although I think he's coming later. He's the one who ran our Java 8 tutorial day. And check out our videos. We video record all of our meetings now, and they're available on our website at tjug.ca/videos. So Java News, thanks for posting news as you find it to the Google Plus community. So we've got a great big piece of news. There is a Java release that came out today that is not a security update. So yay for that.
Is it good or bad?
What's that? Sorry?
Is it good or bad?
Is that good or bad? It's actually a really boring release. I couldn't find anything to say about it. Because they updated the time zone database, which they do with every release. They updated JavaFX and Mission Control, which are sort of like separate products that have their own release cycle, and they get added in to the big JDK distro from Oracle. And as with all the releases lately, it's one of the new security policies. It has a best before date of July 15th. So if you come across a website that still uses Java applets, it will give you extra warnings after July 15th if you try to run them on 7U60. And Java ME 8 came out right at the end of April, just after our last meeting. So Java ME, of course, was the famous OS on every phone for a long, long time. And then Android came out, and that stopped happening. So now they've sort of refocused what Java ME is, and Oracle's really seems to be going hard on the Internet of Things, which is basically embedded computing. So they've got Java ME 8 focused on wireless modules, automotive, smart sensors, all the stuff I listed there. Just little computers, usually ARM devices. And it's available for free, as in beer. And you can get it. They've got a binary for the Raspberry Pi that's like a whole OS. You can download that, and it runs on a Raspberry Pi as is. And also there's a Qualcomm development board called IOE that they've also released a binary for. And there's also an emulator for Windows. So if you do any kind of embedded computing and you like Java, this might be something good to check out, actually. I'm not sure what the advantages of Java ME 8 over Java SE 8 would be on a Raspberry Pi, for example, because that was the first thing I tried with my Raspberry Pi. I put Java 8 on it, and it worked fine. So I don't know. There's probably something special about Java ME 8 that I don't understand. ASF and Oracle are talking about TCKs again. Last time they had a good discussion about TCKs, Apache Software Foundation ended up sort of withdrawing from the Java community process. So this looked like a good opportunity to grab some popcorn and follow along, but they seem to be acting in good faith this time, and I haven't seen any sparks yet in the mailing list. But something to watch for sure. They're basically just renegotiating their access to all the TCKs, which are the test suites you have to run to claim that you implemented JSR publicly. And they're trying to, they had a list of 10 things that they thought weren't great about the current agreement, and they're trying to renegotiate them. But it looks like it's progressing really well. There's this virtual jug that the people behind JRebel started. They have their meetings on YouTube live streams, and they had an interesting panel, or at least I've heard it was interesting because I haven't watched it yet, about the new appeal decision in the Oracle versus Google case, where now it turns out, according to the Court of Appeals, you can copyright an API and prevent other people from implementing the same API using their own code. So that's the current state of the law in the US, is that APIs are now copyrightable again. And you can't just go implement your own Java from scratch, or anything. So there's nobody from Oracle or Google, of course, on either of on the panel, but some Java community leaders discussing the possible implications of this new decision. There's still one more court. They haven't gone to the Supreme Court yet, so there's an expectation from a lot of people that Google will probably appeal to the Supreme Court. So they get the final. They get like the double dog dare, and that's final, whatever the Supreme Court says. And Christian recommended to me. Christian couldn't be here tonight. He's a coworker of mine. He's presented here a few times, most recently with Donnie about Scala. And he recommends this series. It's a 3-part series from Google Developer about compression algorithms. And he said it's fun to watch. It's very informative, and it's only 3 parts, so your time investment is limited. So check that out. It's currently the top thing listed in the Google Developers YouTube channel. I'm planning to watch it. I haven't yet, but I will. And as always, there's the Java calendar maintained by the community. You can check out what's going on worldwide with Java. There's like multiple things every day on this calendar, so lots to see and do if you've got the time. And of course, I always miss stuff. What did I miss this month? Stuff that happened. Nothing. Awesome. I'm sure there's lots to talk about. Anyway, it's time to hear from Ming about Java 8 and so on.
So I'm going to talk about a bit about Java 8 and some of the new things that they'll let us do in terms of accessing databases. So just to get started, I guess databases are amazing. They do all sorts of really cool stuff for us. We all know that. You know, things like having multiplexing multiple people accessing the same data, working out optimal query plans for accessing the data, ensuring things are consistent even if we pull out the power. Databases do all sorts of great stuff. They're totally amazing. The problem is a lot of people don't know how to use them, and this gets us into a lot of trouble. So for example, it's not really their fault. It's easy to make mistakes when using databases. So let's say we have this simple bit of code here, and it just gets a list of all the cities in Europe. So we'll sort of in this code here, we'll go to a database, and we'll run a query to get all the countries in Europe. Then we'll iterate over all of those countries. Then for each of those countries, we'll get the cities that are in each country, and then we'll iterate over those cities, and then we'll just output the names of those cities. And you think, oh, this isn't so bad. It's just 3 lines of code. What can go wrong? But when you actually run this, this is like 50 database calls, right? Because this is a database query, but then when you go over each country, getting the list of cities that are in each country, that's another database call. So you're hammering your database on something that looks pretty innocuous when you first look at it. And you might say, okay, that's the way to solve this is we'll just get, you just write a query specifically for getting things, getting the list of cities in Europe in one call from your database. But the problem is doing queries in Java is just a little bit messy. So for example, here's a query that goes to a database and gets a list of cities, and it checks whether the temperatures of those cities are greater than a certain variable. And so there's some problems with this. And first of all is that the programmers have to learn a new language before they can write any queries. So it isn't too bad. Query languages don't take that long to learn. But the fact that there's this additional barrier you have to go through before you can start writing database code means it's harder to find programmers that can do this, right? You can't get someone straight out of school and say, okay, we need you to write some database queries. They have to spend a couple months reading books and stuff first. Some other issues is that all this code can't be error checked at compile time because all the code is in a string form. The compiler doesn't know what it's doing. So the only way to check whether the code is correct is to actually run it. And this sort of slows down development time, more errors, and et cetera, et cetera.
Is this a Java 8?
This is JPQL code. So I guess like Hibernate and stuff like that. So basically all the benefits of Java in terms of type checking and all that, you lose them once you start using database queries. So for example, here you return a list of the results, but what's in that list? You don't know because what's in the list is dependent on what the string does, and the compiler doesn't know what the string does. So the solution that sort of I'm proposing, or that other people have proposed, is, okay, well, instead of making these new query languages or whatever, we'll just translate Java directly into SQL or whatever query language that you need to access your database. The problem with this is a huge design space. So depending on what sort of system you design, there's different trade-offs you need to consider. So obviously, you just can't translate arbitrary Java code into database queries. So you can only translate a subset. But depending on what subset you choose, you get different systems that are maybe more practical or less practical, or they're easier to program or less easier to program, or sometimes they give consistent results or sometimes not, et cetera, et cetera. One such system, though, is Microsoft's LINQ for C#. So this is a system that Microsoft made. It must be like almost 10 years ago now. And it's a pretty popular system. People tend to like it a lot. And finally, with Java 8, we can start having a similar system for Java. And that's what the rest of the talk is going to be about. OK, so the basic idea is this is what we have to do now if we want to sort of do a database query in Java. And in the future, now that we have Java 8, we can do something like this. So just one line of code. And it should be easy to understand once you sort of learn the new Java 8 stuff. OK? So this is an overview of what I'm going to be talking about. I'm going to give an overview of sort of functional programming in Java 8. Then I'm going to show how with this functional programming support in Java 8, we can start writing functional style queries, database queries in Java. And then I'm going to show you the sort of general idea of how you can build, how a system like this for handling database queries in this way would actually work. OK? So right, functional programming in Java 8. So Java 8 finally brings functional programming support to Java. And this is something we've been waiting for like 10, 15 years, basically forever. And right, we've been waiting for so long. It's finally here. It's great. We can now just start using functions everywhere. It's wonderful. So here's an example, just to give an example of how the functions work in Java 8. So let's say we wanted to sort some strings. OK, so we have a list of strings here, and they have different names inside this, this list. So if we wanted to do this in Java 7, the way we would sort it is we would first call collections.sort, and then we would pass them a list of strings. So we just say collections.sort is a static method that sorts things. And then we need to create a comparator that says how we want to do the sorting. So we create a new comparator object, and then it's a generic object, so we have to pass in the type, so we're comparing strings. And then we have to override a method that takes strings that returns how we want to do the comparison. And then once we're inside the code, we can actually do the comparison. So then we can take the first string, compare it to the second string. And by the time you've written all this, you basically want to kill yourself. This is like a huge amount of code for just doing like something that should be pretty easy. Right, in Java 8, the same code is just one line of code, OK, to do the exact same thing. And if you look at the code, a lot of it is actually the same. So the collections.sort, you still call the exact same method you called before in order to do the actual sorting. And then you still pass in the list. The only difference is how you define the comparator. So this code, the actual code for doing the comparison, this is exactly the same as before. So this just moves over to here. The only difference is you don't have to define all of this. So you only have to define what are the two input parameters to your function. So these two parameters, you just have to define them here. And then everything else sort of Java figures out on its own through type inferencing. So basically, when you write this code, Java will automatically figure out that you're trying to create a comparator. It'll automatically figure out that this code here should go inside a method called compare. It'll automatically figure out that all of these things should be strings. So basically, all of this boilerplate code that you sort of have to write and is really annoying to write, Java will figure out for you, and you only have to write sort of the important part, which is the comparison code. So this is basically, you're right. This is the core of Java 8. This sort of automatic inferencing and expansion of these functions into all this code that you have had to write before. Right? Yep.
Can I say this is just syntactic sugar?
Right. I'm actually going to talk about that.
Oh my God.
So some of you might argue this is just anonymous init classes with less typing. And right, is this just syntactic sugar? In fact, this is right here. So, so you could argue that it is the case. You could argue that's not the case. In reality, it doesn't matter because the difference is that because it's less typing, it fundamentally changes the way we program in Java. Okay, you'd think, oh, just it's syntactic sugar, all of the stuff we could have done before using anonymous inner classes. And that's true, except because it's less typing, we can make APIs that wouldn't be practical before. So some things, for example, here with this sorting, I know like in Java, sometimes I'd have to make a web page and I'd have to display a list in the web page. And I'd think, okay, we should probably sort this. And then I'd try to, okay, I have to write all this code. And then I'll decide, no, this is too much work. I just won't bother sorting it. If someone complains, then I'll write the sorting code. Because it's just so annoying to write this. I'll be like, okay, I forget like what it's called, and I'll forget what the method is. And so I'd have to look up the method. With this, it's like, no problem. I'll just slam this in. It's just, and the idea is that it opens up possibilities for new APIs because of the less typing. And because of that, it changes the way Java works.
Is it a good thing? Like, looking at that last line there, I'm not even sure what method it's called, what API it's calling, like which interface it's calling. What are the arguments, S1 and S2? Like, so is this a good thing for Java?
Is it a good thing for Java? I would
Yes, but
yeah, you just have to get used to the style.
it's great for job security.
Like, I guess the idea is if in a pure functional language, it would look like this anyways, right? Like if you were to write this in JavaScript, it would look sort of similar. So it's no worse than writing it in JavaScript or Python or something like that.
JavaScript should be the bar.
Yeah, okay. Well, like, you know, Haskell or OCaml, whatever, Scala, whatever. So it just makes, like, you don't have to do this. If you still want to write all this code, you can. But it makes Java competitive in this space, finally. So basically, that's all the functional stuff in Java 8, like the crux of it. But one cool thing is now that we have the possibility of having functional APIs in Java, they started adding that to the language. So one of the things they added in Java 8 is something called the Streams API. And the Streams API is a way that it gives you a functional approach to working with large amounts of data. So if you're familiar with Scheme or whatever functional languages you might have learned before, basically you have these stateless functions and you apply them to the elements of a list using operations like map, filter, and fold, okay? And they actually use this in Java for things like Hadoop with MapReduce. So the map and the reduce, the map is basically the map operation for in the functional way of working with lists, and reduce is just a fold operation. So these ideas are in use in Java today, but they aren't more widespread because it's too verbose before. But now that we have better functional support in Java, they can actually make an API for doing this. So yeah, I'm going to cover the Streams API since it's sort of important to understand this, to understand how database queries work. So let's say we have this list of cities here, and it doesn't matter where we get this list of cities from. And we want to filter this list so that it only has the cities that have hot temperatures. So let's say above 15 degrees. So in Java 7, if we wanted to do that, what you would do is you would first create a new list to hold the results. So here we're creating a hot cities variable, which is a list, just an empty list at the beginning. Then you'll take this list of cities that you want to filter, and you'll iterate through all the cities in that list. And then for each of these cities, you'll check whether the temperature is above 15 degrees or whatever temperature you want. And then if it is above 15 degrees, you'll add it to your result set. So if it's above 15 degrees, you add it to hot cities. And afterwards, this hot cities list will contain all the cities where the temperature is above 15 degrees. So this is what you would do in Java 7. In Java 8, so this is like 5 lines of code. It's not too bad. Like most of this is real functional code. It's not really boilerplate. But one thing that's not quite perfect about it is it's sort of poorly abstracted. So let's say we wanted to rewrite this if we had like millions or say billions of cities, which may not be the case, but let's say you had millions of cities and you wanted to filter them. It might make more sense to filter them in parallel across multiple threads. And if you wanted to do that, basically you'd have to throw out all this code and just write some completely new code that creates different threads and iterates things over different threads, et cetera, et cetera. So basically, if you wanted to do the same thing but in a different fashion, you'd have to junk the code and start again. So in that sense, it's poorly abstracted. Now in Java 8, if you wanted to write the same code for finding the cities that are hot, this is what you'd do. So you'd start with your list, your cities list. From there, you'd call the stream method. And the stream method basically gives you access to the stream, the new streams API that's in Java 8. So this is what gives you the stream, right? So that allows you to start using the functional APIs for working with the data in a functional way. And then you sort of filter the data and you check and you write this function here. And basically what this function does is it iterates over all of the cities, and for each city, it checks whether the temperature is greater than 15 degrees, and if so, those are what it keeps. Okay? So if you look at the two things of code, you'll see that the important code is the part you have to write. So you're filtering the code here, and you only want the cities where the temperature is above 15 degrees. That's the code you have to write in the new functional version with the Streams API. But all this other code here, that's basically considered boilerplate, and you don't have to write that again. It's basically hidden by this filter method. So the filter method will go through the trouble of iterating over the list and running this code to see if it qualifies, and then adding things to results set. All that stuff is now in the filter method, so you don't have to write that anymore. You only have to write this part here, the part that says what parts of the list you want. So one advantage of this is now things are sort of abstracted a little bit better, so it becomes easy to parallelize. So here we have code that will iterate over a list sequentially, find the cities with the temperature above 15 degrees and return those. And here's one that does it in parallel across multiple threads. The only difference is here we call stream to do it sequentially, and to do it in parallel, all you have to do is call parallel stream instead of just stream. And
Sequential and parallel. Why does it do it behind the scenes? If it's too big, it will use parallel automatically.
I think you can always call parallel stream. I haven't really looked into details in the implementation, but I assume they could make something that automatically times things and makes a decision. But right, it's functional, so order. You shouldn't write things that depend on the order. But you could, but you aren't supposed to. So right, because all the code for sort of doing the filtering is hidden in the filter method, all the details of doing the filtering can be abstracted out, and that's why you only have to change this small thing. Whereas before, in Java 7, you just have to scrap your code and write everything again and do the filtering yourself. This is abstracted nicely, so you just have to call sort of one method difference. Okay, so there's one sort of weird nuance with the streams, and that's that the streams are lazy. So when you do all these sort of filtering and operations on the stream of data, it doesn't actually do anything with the data. It just sort of sets up a processing chain, and then you have to sort of call something else to actually trigger the processing of the data. So just to go over this examples to make it more clear. So here we call cities.stream. So basically, with your list of city data, it creates a stream of the data. And so basically, you define your data source. Here we filter the data. So we only want the data where the cities where the temperature is above 15 degrees. So all this does is it sets up another step in a processing chain, but it doesn't actually process the data yet. Here we call map. And basically what this says is for each city, we only want the name of the cities instead of returning the whole city object. So this sets up another step in the processing chain, but it doesn't actually do any processing. It's this collect method that we call it then. The collect method is the method that actually causes things to start being processed. So collect. So this collect thing, this method called here, will cause the data to be processed, and it'll put everything into a new list, and then it'll return that list. So when you call the collect, it'll then run the data from the source through your processing chain and dump the results into a list, because that's what you said you wanted to do with the results. Yep.
I'm sorry, I'm still not fully understand the sign of pointer, yes, minus and diff.
Okay. So these are the parameters to the function. So basically, all of these parameters take, they iterate over the data, and then they give you each element of the data in this as C. And then this is what you want to return.
Sounds like apply on C
Right.
this functionality or this
Yeah.
filter in this case, right?
Right. And then if it's greater than 15, it keeps it. Otherwise, it discards it. And this one, it iterates through all the cities. And then for each city, it passes it into the function C. And then it gets the name of the city. And then that will be what it will put in the new list. So is there any, I might have gone a bit fast. Is there any big confusion?
We don't need to worry about return types.
Sorry?
Do we need to worry? We don't need to worry about the return types.
No, everything, type inferencing will figure it out for you.
So what would happen if you've skipped the collect part? If you don't use it?
So it'll set up the processing chain, but it won't do anything.
There's no return?
Yeah, it'll set these up, and then like it won't run any data through it.
If you iterated over the results, it would start processing, right? Or
Sorry?
if you started iterating over what get returned from the map function there, right?
So map returns a stream. So it just says, it basically returns, it's sort of like a linked list of processing things, and it returns a pointer to the last step in the processing chain or something like that.
What can you do besides collect?
There's a bunch of things, like you can do aggregation, like sum things up, put things into a map instead of a list, things like that.
They're called terminal operations in general, right?
Yeah, okay. I don't know the exact
Whatever
details.
starts the data actually flowing.
Right.
So can you skip back one slide?
Sure.
So, so that the bottom part, there's no return in this case?
Yeah, in this case, this sets up the processing chain but doesn't do
So it's
anything.
not saving anything?
No. Right.
So one more question. You could add multiple filters here.
Yes. So you can just add as many filters to the chain as you want.
Is there any way to map more than one value?
Yeah. Well, it basically, whatever you return here is just what's going to be in the stream.
What about the name and postal code?
Yeah. So you'd have to create an object that holds the name and postal code and return that new object. So they didn't get around to making a pair object in Java 8, but I'm sure you could get one from Grava or something.
What about the type? Say, is C in this case the type of C discovered automatically, or?
Yeah, so one of the main things in Java 8 is they added a lot more type inferencing, and it's a lot more advanced, so it'll automatically figure all that for you.
It's based on the cities in this case, right? Until you change the type. Is that right?
Yeah, it figures it out from cities, that it's a list of cities, so the stream will be a stream of cities, and it'll...
Then it will be a stream of strings. Is that right? Once it gets
Right. Mm-hmm. Yeah.
Before you mentioned that it has type inference because it matches like an interface signature. What happens if the interface has two methods? Because before you gave the example of sorting through the list of cities, where I forgot what class it was, but it had the one method of compare.
Right, so interfaces with two methods, you can't use this approach.
Okay.
You can use it, but you need to add a default implementation.
Oh, okay.
Yeah, this is the hairy part of
Yeah, so there's some,
now we have multiple hairy ones.
yeah. Yeah.
So in Java 8, the for comprehension, is it like startup when you do for comprehension, it's null friendly? So in Java 8 for the for comprehension, is it null friendly?
I'm not sure of the details actually.
Like even if it's null, then it just ignore it.
I'm not sure. I haven't tried it actually. I assume it'll just go through, but they might have. Like some people argue it should behave one way or not. I'm not sure exactly what they did.
There was a debate about that, and it was originally not null friendly, but because they said it would be too hard and that it wasn't useful. But somebody from the community demonstrated how to let nulls pass through, and it's not possible. But still, probably a bad idea.
Is it?
Probably.
Okay. Right, so just to summarize the stuff I've been talking about Java 8 so far. So functions are just, you can think of them as a way to do anonymous inner classes with less typing. But because it's less typing, suddenly you can start doing functional style programming in Java, which wasn't practical before. And because we have support for functional programming in Java 8 now, we can now do functional style list manipulation. So we can stream out the contents of a list. We can then filter and transform that data as it streams through. And then we can then collect the data into a new list or wherever. And these are all possible now that we have functional support.
So I have a question. On the same machine, which one would perform better?
Probably the old Java 7 stuff would be a little bit faster, but that's just because they probably haven't spent a lot of time optimizing the Java 8 stuff yet. Theoretically, if they spent a lot of time optimizing the Java 8, they should perform similarly.
Even even for the parallel case?
Well, the parallel case you would have to the amount of code you'd have to do that in Java 7 is like hundreds of lines of code. Like you would, like you couldn't really compare it because it's they have like the huge fork join framework that they use to run this. So I don't know. You're no longer comparing VM issues. It's more how the framework was written.
Doesn't it use like invoke dynamic to actually trigger the execute the lambda? Isn't that faster than just the old way of anonymous in the class?
Right, but if you write it in Java 7, you would just write the code directly. You wouldn't use anonymous inner classes.
Oh, okay.
Does it give a new data type for functions in Java 8?
They wanted to, but there was no way they could get it into the language in time. So like they would have to revamp the whole type system, and like they just didn't have time to do. The question is whether there's function types in Java 8. Okay, so right now I'm going to talk about functional style database queries. So now that we have functional programming support in Java, we can now write database queries in this way. So the idea of functional style database queries is we have a functional approach for working with large amounts of data in lists. So we can use the same approach for working with the data in databases because there's a large amount of data in databases as well. And this is actually similar to C#'s LINQ. And I'm going to show some examples of how these database queries look. And for these examples, I'm going to use something called Jink, which is an open source project I'm working on. And basically, this is a project sort of demonstrates how these functional style queries will work. So here's an example. So in Java 8, let's say you have a list of cities and you want to get the cities where the temperature is above 15 degrees. Basically, this is what you'd write. It's the same as before. You get your cities, you get a stream from it. You filter those cities based on this function here. And if you want to write a database query that goes to a database and gets all the cities from the database and checks which ones have a temperature of 15 degrees, this is the code you would write. And if you look at these two things of code, you'll notice they're almost exactly the same. The only difference is here where you get your list of cities and you stream it out. if you want to do this as a database query, you just go to your database and you get a list of cities from the data, a stream of cities from your database. And then the other difference is instead of filtering, which is what you do with a list, you would call a function called where. And this is just because where is sort of borrows from the database terminology. And some people prefer that. But this could easily just have been called filter, and it would be exactly the same. So that's basically the idea of how you would do database queries in this functional style. So you just use the Streams API and just do them with databases. So you might think, OK, but is this as expressive as other things we can do with SQL or other query languages? And yes, you can sort of. I've only looked at SQL 92 myself, but you can get most of the functionality of SQL 92, like similar expressive power, using sort of this style of functional queries. So let's say you want to do selection, where you filter things from your database. You can do that using a functional style. If you wanted to do a projection, so you wanted to sort of change what gets subsets of the data or get different columns from your data, you can just do that using a select or a map. If you want to join different tables together, you can do that by just sort of from here. You can use a navigational query for each city. You want to get a country from that city, and that sort of automatically expands out into a join. And you can just also call join and pass in a different stream. If you want to chain together your selects and wheres, this doesn't really have a SQL equivalent, but you can sort of reorder your things here as necessary. If you want to aggregate your data, that's similar to
Just go back a second.
So basically, this code here, it goes through the cities and checks if the temperature is above 15 degrees. It checks whether the cities are in a country called Canada. It then gets the name of those cities, and then it returns those cities' names Stratford. Sorry.
Does the order matter in this case?
In this case, well, you'd have to write different code if you change the order, but it doesn't matter. Like you can see in the SQL code, it doesn't matter.
Is generating Java beans for the tables?
In this case, you would use you just use JPA, like Hibernate or something for. Right. So you can do aggregation. So if you wanted to just sum up all the data, you would use something like a collect or whatever. In this case, there's a specific function for summing things up.
All right.
Yep.
What is this different from the criteria API?
Sorry. What?
The criteria API?
So the criteria API, it's sort of weird. The code that is inside the where or whatever, this would be. So basically, the criteria API, they've created a new domain-specific language that happens to be written in Java, but you still have to learn this query language. Like it's not real Java code. Like it's written in Java, but it's not. You can't execute that code. It's not. It's sort of an abstract syntax tree that happens to be written in Java.
How's that different from? I mean, this is the same thing. This is another AST, right?
Well, this is real Java code, so you can actually run this against. Like you can run this code. It's.
But you can run criteria code as well, though. Like it's Java code, right?
Well, it is Java code, but then it's not. It's basically a way of expressing a different query language in a type-safe way with Java. I'm not sure if that makes sense, but you can take this code and run it against like normal data, like in a list, like a list of in-memory data, whereas something like criteria code, it's not. You can't really do that. They've created this language specifically for databases, and then they've embedded it in Java, so you can sort of construct the syntax tree for this other query language in Java. And they try to make it so it looks as close to real Java as possible, but it's like you can't do something like greater than 15 in in criteria. You'd have to call a greater than method and then pass in like some other stuff and things like that.
So what's the type of DB here?
It would be, in this case, it would be something that wraps the entity manager or something like that. You would probably, you'd write that code yourself to return a stream of cities. So you can also do things like grouping. Yeah, here it starts getting a little bit messy, but I guess grouping is possible. And you can do subqueries. I'm not sure if I have subqueries working in the current version of Jink. I've had it working before, but it may not. I'm not sure if this particular subquery works. So basically, the idea is with these sorts of queries. So even with this functional style queries, you get similar expressive query power as SQL 92. In some cases, the syntax looks a bit messy, but I guess the syntax can still sort of evolve a bit. But I'm also not sure whether it just might be an inherent property of complex queries. Like if you're trying to do something complex, you might have to write complex code. I'm not sure if you can actually make it look nice. But again, it's evolving. Maybe that can improve. There are two caveats, though. One is how nulls are treated. In this case, when translated to a database query, they'll run using whatever semantics are in the database. But the semantics of null in the database might be different from the semantics of null in Java. In SQL, we have the 3-value logic where nulls are actually things that you can use in comparisons and stuff. But in Java, if you would actually run the code, you'd get a null pointer exception. So it's not clear. The code you write, it's Java, but then when it's run on a database, it won't be exactly the same as the code you write. The other caveat is it's hard to make new data structures. In SQL, it's easy to return sort of new tables with rows with new names. In Java, that's sort of messy. You have to create a new class. It's hard to sort of write these sort of impromptu data structures just for holding multiple things of data from your database. In Link and C#, they got around this by, I think they added special data types to let you do these sort of 3-valued logic things, and then they added some special features to let you create new data structures on the fly.
That's not really new. If you do that currently with an ORM in Java, you just end up with a primitive array of objects.
Yeah, sure, but it's not pretty though.
You have to know about what that is.
Yeah.
Yourself.
Like I have something here that like you can use pair objects to hold things, and I have tuple objects, but it's just not. It's not as nice as where you have an actual object with named fields. Okay, so some interesting properties of these functional style queries is that the code is executable. So the code that you use to query your database is real Java code, and you can actually run the code as is and not as a database query. So you can just run the code and run it, and it'll stream all of the cities, say, from your database, and you can filter it on your machine. And this is really inefficient, but it's actually possible to just run the code directly without converting them into database queries. So in a way, the running things as database queries is an optimization. It's not really that useful to do this, but it's sort of an interesting sort of way of looking at it. Plus, you get compile time error checking and fewer security issues, which I'll discuss in more detail. So the fact that the code is executable, like, they gives you sort of, just to explore this property in a little bit more detail. Let's say you have a database of weblog visits, so basically all the visits to a web server, and you keep them in a log and you store them in a database, and you want to go over these logs and find all the visits to a certain URL. So you go over each page in your web logs, you check the URL that's being visited, and if it's equal to the URL, you want to keep those. So basically, this is a database query. It's real code, right? I've discussed this all before. If you wanted to use this code to work with objects in memory, all you have to do is, instead of getting your sort of list of logs from a database, you can just get a list of weblog data in memory, convert it into a stream, and then run the exact same code. And another weird twist is that you can sort of use the same syntax for non-database operations. So here, this converts into a database query, but you could also write something like, for each page from the database, get the IP address and look up the country, like go on the internet and look up the country where the IP address is from and check whether it equals to Canada. So this code can't be converted into a database query because it goes onto the internet to look up a country. But you can still write it using the same sort of functional syntax. I'm not sure what the use of this is, but it's sort of an interesting property of these sort of functional style queries. That comes from the fact that this is real Java code. So another nice thing is that your queries have fewer errors. So here you're, right, in JDBC or JPQL or whatever, you always have to write your queries as a string. But because this is real Java code, it can be checked by the Java compiler and checked for errors. Here we have a SQL injection error because someone was just too sloppy to use a set parameter. They just threw in the string right there. That's not possible with sort of these functional style queries because all the executable part is written as real Java code. This is all properly type checked, whereas with JDBC you can't do the type checking. Because this is real Java code, you can also get code completion. So if you have your page and you aren't sure what sort of are the methods on page, this is actual real Java code. Your Java compiler, if you press Control Space, it'll give you a list of methods, and you can just use your code completion to get stuff. So to summarize, I've shown you that you can use sort of this stream syntax to query databases, sort of this functional syntax. The power of this sort of syntax is similar to SQL, and they have some weird properties, like the code is executable and there's fewer errors. And now I'll discuss how you can actually get the system to work. So I showed before that the queries are written using real Java code, but because it's written in real Java code, it's not clear how to translate this into SQL or whatever database query language you want. C# with its link, in order to get this to work, where you write your database query code in C#, they had to change their compiler specifically to support this. The problem is when you do these sorts of changes, it's sort of inelegant because it's not general purpose. It's like these changes are specific to getting database support to work. And although they've tried to use the mechanism for other things, they haven't really found anything useful to do with it besides letting you write database queries in C#. And because it's only useful for database queries, it's probably unlikely to ever get into Java. So if you were to propose to the Java standards people, or we want to add database support right into the language, basically it would take 10 years for them to agree to it. And even then, it would just take too long and it probably wouldn't happen. So you'd need to find some other way of sort of implementing this sort of stuff. Now you could just make sort of a custom compiler that would support this. The problem with custom compilers is they sort of have poor integration with these existing tools. So I could make a special Java compiler that had support for sort of these functional queries, but would it work in Eclipse or NetBeans? Probably not. And then every time they came out with a new version of Java, you'd have to come up with a new compiler. It's sort of a bit of a mess. So the way around this is to use bytecode analysis instead of mucking around with the compiler. And the reason why you can use bytecode analysis better than writing your own compiler is that the bytecode format for Java is fairly static. Like, it doesn't change that much from version to version. So if you write a mechanism for supporting databases through bytecode analysis, it will probably be supported for a fairly long amount of time. The problem is it's a little bit tricky. And two ways it's tricky is that different compilers produce slightly different output. So you need some sort of mechanism that can handle these sort of different outputs that a Java compiler might output. And it's also just basically hard to translate imperative code to query code. So query code is declarative. Imperative code is just a sequence of instructions of how you want to actually execute something. And this translation is pretty rare, so it's not 100% clear how to do it. So I'll give an example of how it's done in Jink, just so that you sort of understand what's going on behind the scenes. So let's say you have this code here. It's the same code as before, where we have a database query that goes to a database, gets a list of cities, and checks whether the temperatures of the cities are greater than 15 degrees. The different compilers might compile it in different ways. It might compile it like this, or it might do something with ifs and gotos and something. This is actually closer to what the Java compiler actually produces, but I'll use this as an example just because it's shorter. This isn't real bytecode because it'll take too long to go over bytecode, but it's our simpler code that will give you a feel for how the algorithms for the translation works. So basically, the idea is when you want to generate a query from your code, this is what you'll see in sort of the translation algorithm. And you have to generate a query from this. And if you want to generate a query from this, you basically have to understand what it does. And one way to understand what it does is you pass some parameters, run it through the code, and see what happens. So one thing you can do, so just an example, you'd have some fake data like Toronto 10 degrees. You'd run it through this code and check what happens. Run it through the function. So basically, you want to keep track of all the things that change in the state of your program by running the code. So first, you set the input to the function to Toronto 10 degrees. Then you run this code that sets a to 15. So this is something that changes when you run the code. This a variable becomes 15. Then you want to get the temperature of C. C is Toronto 10 degrees, so the temperature is 10. So this is assigned to B. Then you want to compare B to A. In this case, B is smaller than A, so C becomes false. And then you return C, so C is false, so you return false. So this is basically what you do as a person if you want to sort of understand what the code does. This is obviously not practical for a computer because the computer can't just make up random data and try to understand what goes on. So if you want to get a computer to sort of use the same approach to understanding code, one thing you can use is something called symbolic execution. And basically, you make fake data and run it through the code, but the fake data is basically composed of symbols, and you sort of execute the code using symbols instead of with real data. So in this case, instead of having C be Toronto 10 degrees, C is just the symbol input. So there's some input, we don't know what it is, and we're going to run it through this function. So when you get the input, C is input, so C is the symbol input. Then we run the first line of code, A is 15, so we know that A is 15. Then we get the temperature of C, and C is just the symbol input. So when we get the temperature of C, basically we get the input symbol and we get the temperature of that. And this is what we put into B. Then we check whether B is greater than A. So in this case, B, which is this, goes here, and then A, which is this, goes here, and we put that into C. And then we return C, so C is this huge sort of string that we've computed, and we just return that. And then, so basically, this is the result of executing this code symbolically. And these variables here are local variables, so once we exit the function, they don't matter anymore because anything we store in them is gone. So basically, the effect of running this function is this. It returns the input to the function, we get the temperature, and we check whether it's greater than 15 degrees. So from this, we can, now that we know how to understand the code that's passed in as functions, we can then sort of start generating queries using this sort of understanding. So this is how query generation works. So when you call your database and get a stream of cities, this is sort of the SQL query that would be generated to get all the cities in the database. And then when you call this where method and you pass in this function, what happens is inside the where method, it looks up it uses the symbolic execution to understand what this function does. And running the symbolic execution, it realizes what this function does is it gets the input, it checks whether the temperature is 15 degrees, and that's what it returns. And from that, it can just add this to the query, and this is how you generate your query. So this is the basic idea of how the query generation works. And so all the, it skips a lot of details, but this is the general idea of the algorithm. So the basic idea of the inner workings, it's sort of messy, but it works. And because it's all done through bytecode analysis, it integrates well with existing Java toolchains. So all this, it can be done at runtime. So you don't need to change your compiler, your debugger, your refactoring tools, all that stays the same. It's just at runtime, it automatically converts things into queries. And it's actually pretty reliable. So there's no surprising behavior. If you write things in a way that can be converted into a database query, it'll be converted into a database query. Right. So in conclusion, Java 8 has support for functional programming now. And now that we have support for functional programming, we can finally get functional style database queries. And because LINQ is so popular in C# and people have sort of been demanding the same thing for Java, it's probably inevitable that this will eventually come to Java in the future as well. And if you want to try it out, there's an open source project that I'm working on called Jink that you can try it out, and it now has support. I've most recently added support for sort of Hibernate, and so you can sort of start using it if you already have a JPA project. Okay, that's it.
What about if we need to select big volumes of data? Is there any support?
So select before. Big volume of data, millions of rows. Mm-hmm.
Will I run into problems of performance or whatever?
Well, like it's all translated into a database query, right? So it's all run on the database. What?
So it's actually the same as it was before.
Yeah. Assuming the query generation works, what you write will generate a real database query that's as efficient as just writing the database query yourself. Yep.
You said that the query translation can be done at runtime, but is it necessarily done at runtime?
Well, the implementation. Well, you can do it. If you do it before runtime, you need to add an extra step to your Java toolchain. So it's possible. It's just it's really hard. You'd have to shoehorn it into your build system somehow, and I'm not sure people want to do that. Yep.
So how is it, your example is db.citystrings, right?
Mm-hmm.
So I assume the city could be a JPA entity, right?
Right.
How does that, I add a new entity, how does the DB object now have access to, do you have any code that shows how it actually integrate that with JPA?
Yeah, so I guess I have a slide here. So basically, you'd have, so you have your entity manager factory, and the entity manager factory, your entity manager has information about all the JPA classes. So basically, you pass it into this thing that generates streams from JPA from your entity manager. And from there, you can then, so this is called streams. From there, you can generate a stream just by passing in your entity manager and then the class you want to stream out of your database. And
you talk a lot about select.
Hmm?
You talk a lot about select. But there's other verbs in SQL.
Yeah. Well, like the key, the main power is select and where, and then the subqueries. The other stuff is a lot of is syntactic sugar. If you can get the subqueries and the select and where working, then the other stuff sort of falls in.
Well, okay.
When are you gonna release a proper release for Jink?
I don't know. I'm only one guy, right?
My question is really have you looked at the Scala's slick implementation?
Yeah. So I'm from EPFL, so that's the university that produces Scala as well.
Okay.
So I know those guys. Yeah, it's everyone sort of has been discussing. They have a different implementation where basically they have a way of overriding the compiler. So it's like an extra stage in the compiler that you can sort of plug in. For Java, like I said, it's not practical in Java because Java won't let you sort of muck around in the compiler like
those extensions?
I'm not sure of the exact implementation, but in order to make this practical in Java, it's just easier to do that through bytecode analysis.
Right.
With Scala, because they control the whole language and they're sort of more receptive to changing the compiler to add these features like database support, you can do it that way too.
Well, my real question is, Scala still doesn't do the invoke dynamic. That means it's still slower because they have their own sort of way of generating the class to get around the bytecode, the JP.
Right. But all of this is translated into database queries, right? So it doesn't matter the implementation of the functions. It's all ignored once it's compiled to a database query.
I like to see a port of Slick for Java, meaning that using Java 8, using all the Lambda stuff to do Slick. Because even if I use Slick now, it's going to be still slower for native Java implementation.
Yeah, I assume the TypeSafe people are working on it. It's just a matter of time, right? Like Java 8.
Java 8?
Yeah, well, yeah, of course, right? Like if it's faster, they're going to do.
Like 2.3 or something.
Yeah, like they're getting paid for it now, so I assume they're going to do it at some point. Okay, so I guess that's it. Oh, yeah.
Just one more question about your queries. So in a lot of cases, when you're working with databases, you need to build dynamic queries. What's your thought on that, or is that not appropriate in this situation?
Yeah, then you'd use like the criteria API or something like that, or yeah. Like you can sort of do it a little bit. Like these queries, like this is all done at runtime, so you can compose them as you want.
Sure.
But the code in here, like that has to be static.
Like, could I assign it to a variable and then, conditionally manipulate that variable?
Yeah, sure.